Okay, so we are in Introduction to Statistical Learning. We're in Chapter 12. We're just starting, and we're in the conceptual questions, question number 1. This entire chapter deals with unsupervised learning, and among those methods discussed is clustering methods. And here we're talking about the k-means clustering algorithm. Okay, so here's the question. The k-means clustering algorithm uses this expression or this identity right here. And so for part A, we're going to prove that identity, and then we're going to look at the algorithm that in part uses this identity and show why the k-means clustering algorithm works at all. So again, we want to show that the left-hand side equals the right-hand side. So there's a lot of ways we could do this. So we could start with the right-hand side and manipulate it to get to the left-hand side, or vice versa, or show that they both equal some intermediate form. But what I have done here is to take the left-hand side and just manipulate it until we get to the right-hand side here. Okay. Just a little bit of background here. So this left-hand side here, the book refers to this as W of C of K, and that is the within cluster variance or variation. And what k-means is trying to do is, for any number of clusters, it is trying to minimize that value, the within cluster variation. Okay? So in other words, it wants to assign clusters such that within any given cluster, the Euclidean distance between each pairwise pair of points within that cluster is minimized. And what this identity is saying is that we could also find the difference between each data point in a given cluster to the mean, or the mean of that cluster, and that those two things would be equal. Okay, or at least these two expressions. So 2 times instead of 1 over the number of clusters. So all right, so I won't walk through this because it's kind of silly to walk through math, but I'll just kind of get some signposts here. So I just start with the left-hand side, and right away, just to save myself some typing, I get rid of this bar CK notation. I just use NK. That's just to save myself some typing. Okay? But we go through, we expand this polynomial here, and then we can push through this first summation symbol into each one of those terms, and we get this thing, and then we just go about solving each of those summations, and eventually we get to the right-hand side here. Okay. Now in part B, we are going to argue that the k-means clustering algorithm, which I've pasted here, that this decreases the objective function 12.17 at each iteration, and this is 12.17. And so what is the objective function here? Well, this is the if we don't sum over, each one of these terms right here is the within cluster variance of some cluster, the kth cluster, and we take that over all clusters. We sum that, and then we want to minimize that. Okay, so that's what's happening. That's the objective. That's what we want to do. Okay, and the algorithm is to randomly assign. So first we need to say how many clusters we have, and then we randomly assign each observation to one of those clusters, 1 through capital K. Okay, and these are the initial cluster assignments, but it's probably not good. So we need to iterate some algorithm to, again, achieve our objective here. And the way that this algorithm works is that for each of the k clusters, which remember at this point was step 1, these are just randomly assigned clusters, okay? But for each of those clusters, we find the centroid Okay, so that's basically the middle of the points in the cluster. Now remember, these clusters exist in some dimensional space, so that center, quote unquote center, could be in the center of n-dimensional space, or it's in the middle of some n-dimensional space. Anyway, and then so now we have a set of k centroids, and now we reassign each observation to the cluster that is, or to the centroid that is closest. And now we iterate. So now so we've newly assigned our clusters, and now we find again the centroid and reassign once again each data point to its closest centroid. Okay, so we need to think our way through that algorithm and show that it decreases the objective function, this guy, at each step, at each iteration. Okay. So the easiest way to see this for me is to just think about this very first assignment, which is just random. Okay. So we have a random set of observations, or I'm sorry, a random assignment of our observations, and so that's going to have some within cluster variance, okay, summed over each cluster. Well, simply by reassigning the observations to the nearest centroid, this, all of these values here are going to shrink. Okay. Another way to say that is, not only is this expression, this parenthetical expression, going to shrink, this expression is going to shrink, where the x bar is, basically the centroid, right? So if we are purposefully reducing or assigning values to their nearest centroid, well then of course that distance is going to shrink, and because this is the same as this, which is the same as this, then our within cluster variation is just going to consistently decrease with each iteration. So I hope that's enough of an intuition. I hope it follows without me having to do a bunch of basic arithmetic to show that, but that's the basic idea.